In this video, I will review the answers to quiz review number 1. So the first problem presents us with categorical data, favorite types of snacks students munch on when they study. We have to construct a categorical frequency distribution. It has 4 columns. The labels are class, tally, frequency, percent. Class will consist of each category, so we list all the categories: candy, chips, cookie, donuts, fruits, and veggies. For the tally, we basically count off each data item as they occur in the data set. So if we look at candy, we can see that there's 1, 2, 3, 4, 5, 6, 7 occurrences. And repeat that for all the other categories. Frequency, we just write out the actual numbers of the tally, so we count up the tally marks. For candy, it's 7, chips 7, cookies 5, donuts 5, fruit 4, veggies 2. And then for percent, let's look at a calculator to perform the computation. We need the sum of the frequencies. In this example, it's 30. So to compute the percent of candy, we would take the number of occurrences, which is 7, divided by the sum of the frequencies, 30, and we will get a decimal answer of 0.23, and then just the 3's repeat infinitely. To convert this to a percent, we multiply by 100. So it's 23.3%. But I'll round to a whole percentage for this example. So we end up with 23% for candy and for chips, because chips has a frequency of 7. For cookies, the frequency is 5. So we take 5 divided by 30.16666 times 100. So we have 16.6. Since this number is greater than 5, we round to 17%. That's true for cookies and donuts. And then repeat the same process for the fruits and veggies. Looking at number 2, we're presented with quantitative data, and we have to develop a grouped frequency distribution. The number of classes is 7. So first we calculate the range. We take the highest value, 118, minus the lowest value, 28, to get 90. Then we calculate the class width. It's 90 divided by the desired number of classes, 7. We get a decimal result, 12.857, which I rounded to 3 places. But remember, when computing the class width, we always round up to the next whole number, 13. When constructing our table, we need 4 columns. We need class, class boundaries, tally, frequency. When constructing the classes, we always begin with the lowest value. So the lowest value is 28, and then we add 13, so 13 plus 28 is 41. Always start with the lower limits first. 41 plus 13, 54. 54 plus 13, 67, and so on. To get the first upper limit, so these are called the lower limits. To get the first upper limit, we subtract 1 from 40 to get 40. Add 13, 53. Add 13, 66. Add 13, 79, and then just keep repeating that pattern to get all the other upper limits. Since we have gaps in our classes, and ultimately we have to graph this frequency distribution, we need to close the gaps. To do so, we use what's called the class boundaries. So we will subtract 0.5 from the lower limit, add 0.5 to the upper limit for each group. So subtract 0.5, we get 27.5. Add 0.5, we get 40.5. and repeat that process. Subtract 0.5, 40.5, add 0.5, 53.5. And then that process is just continued for every group. To tally the data, we have to determine which class each data value belongs to, and then place a tally mark in that appropriate class. So for example, 63, that would fall in the third class or third group, so we would place a tally mark. 46 falls in the second class, second group, however you want to phrase it, put a tally mark. And then just repeat that process for all the other data values. And once we have all our tally marks finalized, we just count them for the frequency. So we have 4, 3, 7, 1, 3, 2, and 5. Next, we have to construct the graph of the histogram. So we draw the x and y axes. On the x-axis, we place the class boundary limits. So if you notice, some of the class boundary limits repeat. So what I typically do is I take all the lower class boundary limits plus the highest limit, class boundary limit, and I place them all on the x-axis. And then I look at the pair. So the first rectangle will be constructed using this first pair of class boundary limits. On the y-axis, that uses frequencies, so we want to make sure we have consistent units there. So if we go back to our table, the first pair of class boundary limits, 27.5 to 40.5, has a frequency of 4. So we go up 4 units and construct the rectangle. The width of the rectangle is the distance between the class boundary limits. The length will be the frequency. And then just repeat that for all the other class boundary limits. So for 40.5 to 53.5, the frequency is 3. So we go up 3 units, construct a rectangle until all of them are completed. And then typically you try to see if there's any type of recognizable pattern. That doesn't look to be the case here, right? If anything, it looks like there's like a decrease towards the center of the amount of items per group. Now for the frequency polygon, we have to compute the midpoints. So the midpoints would be all the values that are at the center of the classes. So it turns out that if we were to find the midpoint, and there is a formula, we just take the lower limit plus the upper limit, divide by 2. So if we calculate this here, let's take a look using our calculator. We have 28 plus 40. We add the 2 limits, we get 68. We divide by 2, and that's going to give us 34. So the first midpoint is 34, and then it has a frequency of 4. So at 34, we go up to 4. And then we could repeat that pattern if we were to take 41 and 53. So we add 41 plus 53, divide by 2, we end up with 47. So 47 represents this class. 47, we go up 3 units. Now it turns out that all the midpoints are also separated by the class width. And we found out that the class width is 13. So to find this next midpoint, just add 13 to 47. That's going to be 60. We go up 7 units. Add 13. 73, go up 1 unit. And just repeat that pattern. Once we plot all the points, we then connect them with straight lines. And then the final step is we have to connect this first point back to the x-axis at a hypothetical midpoint. This midpoint does not exist. To find this midpoint, you take 34, because remember, the midpoints are all separated by 13, so we take 34 and subtract 13, and that gives us 21. We anchor this first point to the x-axis at 21, and similarly on the right side, we add 13 to 112, to get 125, and then anchor this last point to 125. That is the frequency polygon. And then finally, for the last problem, we have to construct the ogive. To accomplish this, we need to first build the cumulative frequency distribution. To build this distribution, we list all the class boundary limits like we did previously. And then we have to find the cumulative frequency. So let's go back to the group frequency distribution. So we start here with 27.5. Remember, the cumulative frequencies are the sum of all the frequencies that precede this limit. Well, there are no frequencies that precede that limit. So the starting point is always 0 for any cumulative frequency distribution. Then we go down to 40.5. Well, the only frequency that precedes it is 4, so that's our next value. Then we go down to 53.5. There's two values that precede it. We add them together, so 4 plus 3 is 7. Go down to the next limit. We have 7 plus another 7 is 14. And then just think of it as a running total. We just keep adding the next frequency to the total. And that's how we were able to derive these values here. So 0, 4, 7, 14, 15, until finally the last boundary limit is the sum of the entire column. Next, we graph this table. We place all the class boundary limits on the x-axis, all the cumulative frequencies on the y-axis. In this example, we went by units of 5. We plot the points. 27.5 is 0 on the x-axis. 40.5 is 4. 53.5 is 7. And so on. You plot all the points. Finally, connect the points with straight lines. And that is the ogive. Thanks for watching the video.